Hello, my name's Paul Williams and I am the Director of Development and Quality Control here at KMP. I've been at KMP since 2004 and been in the industry since 1987. I'd like now to hand over to our engineers who will take you around our metrology lab, showing you the various tools and equipment we have to ensure that the parts are to the KMP brand specification and will meet the customer requirements in terms of service life and performance.
Hi, I'm Hattie Cockrell and I'm the Quality and Engineering Manager here at KMP. I have a Master's in Automotive Engineering and I'm an Associate Member of the Institute of Mechanical Engineers.
Hi, I'm Harry Martin. I'm a Quality Engineer here at KMP. I have a Bachelor's degree in Motorsport Engineering and a Master's degree in Advanced Product Design and Manufacture.
Hello, my name is Nضمن. I'm one of the quality engineers in KM Product. I have a bachelor degree in industrial engineering and I previously worked in product development.
So this is the KM Products laboratory where we carry out a lot of our testing. We have a lot of hand equipment as well, but specifically in here we've got some of our big bits of machinery which we're just going to talk you through briefly what each piece of equipment is and what it does and what we use it for.
So this is our equipment measuring machine. This is one of the most expensive bits of equipment we have here. We use this for all of our geometric measurements. It allows us to create programs. We measure camshafts, crankshafts, and mainly pistons on this machine.
Over here we have an XRF analyzer. This is used for testing the material specification of different parts. So it can be used on any size piece of equipment. We do have a lead line box for any of the smaller pieces of equipment, but we're able to measure a large proportion of the periodic table as we've seen here.
We then move on to our shadow graph. So our shadow graph allows us to measure particularly valves, its symmetrical components. It projects a shadow and then lots of mirrors rebound the image onto the screen here. And we use a digital readout to measure off certain data points, and it's nice, quick and easy and very down to a micron. Our more extreme piece of equipment, which will replace this.
So as Harry said, the upgraded version of this is our digital microscope. So as can be seen here, the digital microscope can be used to measure down to a micron on lots of different pieces of engine parts that we develop. So for example, piston rings, valves, you can also look at different failures for crack propagation and things like that. And it's a more up-to-date version of the shadow graph. Having said that, we still do use both.
We come on to our hardness machines. We've got two, but this one specifically is our lead hardness. This is our portable hardness tester. It allows us to obviously move the tester to wherever the piece of equipment is, because sometimes we have humongous crankshafts which needs testing.
On the side of that, we also have our Avery hardness tester, and what this does is drop a weight of 100 kilograms onto the valve. So this is a form of destructive testing. And it will look at how much the material pushes back, essentially the force that comes back, and we'll get a reading in HRC. And this can be used for things like valve tips, valve stems, but also any other smaller parts which need to be hardness tested.
We have two remaining bits of equipment. The second one is the surface finish tester, which we use to test mainly rollers, tappets and liners to ensure that you've got the correct sort of depth of grooves and allow the correct oil retention within those components.
And finally, we've got a tangential tensioner.
This is used to measure the tangential tension of piston rings, which is the amount of force that's exerted onto your liner or your ball. This ensures that you don't get blow-by within the combustion chamber, and also just ensures you get the correct combustion ratios.